So now we're going to talk about adding it somewhere arbitrarily in the middle of the list, maybe in the middle, maybe at the head, maybe at the tail, we don't know. And there's a bunch of different ways to do this depending on what kind of information your node has, or what information your nodes possess. But for right now, I'm going to do this by index. So this is a linked list, not an array, right? So there's no kind of built-in indexing like there is for an array. We can't just say, oh, the 7th item in the linked list, that's the one that I want to add after or before. We have to actually kind of count our way, crawl over this linked list and count our way to that spot. So this requires an index that you want to add at to be passed as a parameter. And we have to check if that index is valid. If not, we're going to want to print an error message. And if the index that whatever is calling this function wants to add to is 0, well, that's just the beginning of the list. So then we're just going to call add at head, and it's going to do it for us. So you can see my checking to see if the index is greater than the count, because if it's less than the count, checking to make sure it's less than the count but greater than 0, because otherwise we're going to have like a bounds error. We're talking about an index that isn't within the range of numbers of nodes in our linked list. So then if we pass that, then we are going to check if it's equal to 0. If so, we're going to just call add to head and pass the new name node. Otherwise, we're going to traverse the array to find the index. So we're going to make a new node, and we're going to make 2 node references, not new nodes, node references. One, you can kind of call them what you want. There isn't an official name that you have to call them. Generally, one should be like temp or current or something like that, and one should be previous. And that's what I'm going to use in this example. And the point of doing this is so that we can crawl these references along our linked list until we find the location where we want to add the new node. So we're going to use a loop to do this. And one reference, the one called previous, is always going to stay one node behind the other reference, which makes sense. So we can keep track of what the previous node is. So we're going to let the new node point to the node currently at the desired index. This is once we found this, the index that we want to insert it at. We're going to make the new node point to whatever node is currently at that index, right? We're going to say, move over, we're taking your spot here, push everything to the right or to the left, depending on how you're imagining this. And saying, okay, this is my index now. I'm going to point to you. And then we're going to let the node at previous refer to this new node. Because before, the node at previous was referring to the node that's currently at the desired index. So we're just going to wedge our new node in between those 2 other nodes and preserve our links through the next node references. So this is what that looks like. So we are going to make a new node. We are going to make the temp, set it equal to head, set previous equal to head, and then we're going to say for integer I equals 0, I is less than the index that we want to find, right? And then we're going to increment I until we get to that index. And we're just going to set previous equal to temp. So now they're the same, but then we're going to say temp is equal to temp.next. So if you're imagining this, we're kind of advancing temp and previous up the linked list until we stop at the index. So now that we found the index, we say new node.next equals temp, previous.next equals new node. We've preserved the integrity of the list and successfully inserted the node at the the new node at the desired index. So we can just increase the count and we're finished.